Solve the system of inequalities. Y is less than 1/2 x plus 4. 5x plus 2y is greater than negative 16. Let's first graph the first inequality. Y is less than 1/2 x plus 4. The first step is to graph this as if it were an equal sign. Y equals 1/2 x plus 4. Since this is in the form y equals mx plus b, we already know the y-intercept to be 0, 4, since the b value is 4. To find the x-intercept, we can let y equal 0 and solve for x. If y is 0, we have 0 equals 1/2 x plus 4. Subtract 4 to both sides to get negative 4 equals 1/2 x, and so x equals negative 8 by multiplying both sides by 2. So the x-intercept is negative 8, 0. We can use these 2 points to graph this line. The y-intercept is 0, 4. The x-intercept is negative 8, 0. Before connecting the dots and drawing the line, we have to reference the inequality. The first inequality was y is less than 1/2 x plus 4. Since it is a strictly less than, we have to remember to graph this as a dashed line. And the last part is to shade on one side or the other of the line. To do this, we need to find a test point. The test point must be a point that is not on the line. And the most convenient one will be 0, 0. So let's take our test point 0, 0 and evaluate the first inequality. So if the test point is 0, 0, the first inequality becomes 0 is less than 1/2 times 0 plus 4, which when we simplify becomes 0 is less than 4, which is a true statement. That means we need to shade this graph on the side that contains the point 0, 0. And we shade that by making these marks. Now let's handle the second inequality. The second inequality we're going to handle the same way. First graph as if it were an equal sign. 5x plus 2y equals negative 16. To find the y-intercept, we always let x equal 0. In this case, if we let x equal 0, all we're left with is 2y equals negative 16. And solving for y, we end up with y equals negative 8. So our y-intercept is 0, negative 8. To find out what the x-intercept is, this time we let y equal 0. If we let y equal 0, now we have the equation 5x equals negative 16. And solving for x, we end up with x equals negative 16/5. And so the x-intercept is negative 16/5, 0. Let's plot those 2 points. I'll plot those in red. The y-intercept is 0, negative 8. The x-intercept is negative 16/5, which is approximately a little more than negative 3. Once again, before we draw a line through these 2 points, notice that the inequality for the second inequality is a strictly greater than. Therefore, the line must be dashed. Making the dashed line, and now we must find a test point. To find the test point, We take a point that is not on the line, and again, a good point to choose is 0, 0. Evaluate the second inequality, and we get 5 times 0 plus 2 times 0 is greater than negative 16, which gives us 0 is greater than negative 16, which is also a true statement. Therefore, we must shade on the same side as that point 0, 0. So what is the solution to this system? Well, a system means that the solutions must be solutions to both of those inequalities. So graphically, it means wherever these two shaded regions intersect is the solution set. So erasing the parts that are not intersections, we get the true solution to the system. And so the solution is this waffled shaded region.